So this is about enzymes. We talked about photosynthesis, chemosynthesis, and respiration, and all those are run by enzymes. We talked about enzymes briefly in the chemistry unit, and we're going to talk about them more now. Um, and we're mainly going to focus on factors that affect them, because this is very relevant to the real world, and I'll talk about that here in a second. So your goal for today is you should be able to describe what an enzyme is and what it does, and you should be able to predict how enzymes react to changes in temperature and pH. So on your notes, I'm not going to write that because it's written out right for you, but you can write that right there on your objective. And then we have the application. So I told you this stuff is important to understand how everyday things work. So there's enzymes in every cell of your body. And what you eat is, first of all, they're the ones that digest everything that you eat. So you think normally stomach acid breaks it down. Well, stomach acid is more just there to protect you against pathogens that get into your body. But the enzymes are what breaks it down. So for example, when you put bite into a sugary apple, it's breaking down that sugar and actually making it taste better. And it's what digests pretty much everything, but it can also build things up, and we'll talk about that later. And this actually helps you understand why we do the things to preserve food and why we feel so crappy when we get a fever. So now we're going to get into the nitty-gritty here. So, what are enzymes? So we already talked about this in a previous unit, so this should just be a reminder. Enzymes are proteins, and since they're proteins, they're made of amino acids. So on your note sheet here, we did the objective and application. So what are enzymes? Enzymes are proteins, and since they're proteins, their monomers, remember, are amino acids. So remember, the monomers are the single units that make things up. So the amino acids are their monomers, or their building blocks. Alright, sorry about my crappy handwriting, but it's on the PowerPoint slide if you need to see it. So if we go back here, and I'm going to have to erase this. So we got what enzymes are. Now we're going to look at what they do. So enzymes, so here's our substrate. So this could be, let's say this is a bite of the sugar that you ate. It goes into the enzyme. The enzyme fits it perfectly. You notice how the shape here, so it has this little triangle shape here that fits with that. We're not going to go too much into that, but that's very important. And then it will break it apart into two products. So if this was our, like our spaghetti, it will break it apart into two products, which would be our two glucose molecules, or our two sugars. Alright, so it basically breaks our polymers, or polysaccharide, into monomers. Alright, and this would naturally happen, but just think as if you but enzymes cause it to go faster. So think of like a toothpick. If you have a toothpick, it will basically biodegrade and it will turn into nothing over time. However, if you take a saw to that toothpick, it's going to break up really, really quickly. That enzyme is like that saw. It's breaking it down very quickly. Alright, so let's go to our notes and fill that out. So, enzymes. Oops. So down here, we're on part 2 now. Enzymes either break down the substrate. The substrate is the thing that it acts on, or it will put two substrates together. So I didn't show that in that picture, but those whenever you build muscles, enzymes are putting together those muscles to build up muscles. And the second thing that I said is it's like a salt. It speeds up reactions. Alright, and again, this should all be review from the chemistry unit. Alright, so it speeds up. It's that high octane fuel that you put into your car. Alright, so now we're going to focus on enzyme factors, and this is where we're going to spend the majority of our time. So let's look at the three things are going to be temperature, pH, and substrate concentration. So All enzymes work at the best temperature or pH, and that's because the enzyme wants to be this shape. So remember how I said these shapes fit perfectly? What happens if you get to too high of a temperature, this shape will change. So it will start not working. It won't fit very well with this shape. And same with the pH. If you change the pH, it will change the shape or denature the enzyme, and it won't be able to fit with that. So we're going to look at graphically what that does to our enzyme. All right, so all enzymes work at, we're going to start with temperature. They all work at one specific temperature, which is up there, our optimum temperature. And if you get cooler, it slows it down because the molecules move slower. And if it gets warmer, it speeds it up. All right, to a point where we're here, our optimum temperature, but then if you get too warm, remember I said it changed the shape. If when it starts changing the shape, it starts denaturing, and then eventually it doesn't work at all. So this is why a fever is so important to get down, because as you get higher and higher in your fever, if you get too feverish, your body will actually just shut down because your enzymes will no longer work. All right, so let's look at this on the notes. So down here, so enzymes work best at one temperature, and that is called the optimum temperature. So you can remember that by Optimus Prime from Transformers. If you know who he is, he's the best transformer, so optimum means best. So let's take our body. So your body temperature has to be at 98.6 degrees. So let's just say down here on our temperature graph, we'll put 98.6 right in the middle, just to make that easy. All right, and then we'll go like, so this would be 99, 100, so you guys should follow along and write this stuff on 97, 96, and so on. All right, I'm not going to fill out the whole thing. You'll get the picture. So if this is the optimum temperature, 98.6, that means our enzymes are going to be working the fastest. So our point, that should be the highest point. All right, so I'm going to put that right there. All right, and then from over there, when we start getting cooler, we could go into hypothermia, and we start getting cold, and our enzymes start to work worse. And then if we get too hot, we get feverish, our enzymes start to work worse, and they go down. And then on either end, we could eventually die because our enzymes are not working at all. All right, and this up here is our optimum temperature. All right, and the key thing to get out of this is that if we heat it up or cool it down, enzymes slow down. All right. So we'll summarize that here. So if you flip to your next page, enzymes in our body work best at the optimum temperature, or 1 temp, and this is different for all enzymes. Like some bacteria really like it really, really hot, and that is why it's dangerous if we get too cold or too hot. So let's look at some other applications. So if you leave your food out on the table, it's going to go bad. The reason for that is, first of all, dirt and germs and bacteria and stuff get on it. However, also the enzymes in the food start breaking it down. That's what we said enzymes do. So if you slow it down by putting in the fridge or floor, it's too cold, so we slow down the enzymes, all right, because it's too cold. We heat food up also to kill the bacteria and stuff in it, but also it will actually stop or slow down the enzymes. I already wrote enzymes there. So slow down the enzymes of the bacteria that might make us sick, or whatever pathogen might be living in there. So we actually kill it. So again, we're slowing down those enzymes. So if it's too hot or too cold, you slow down the enzymes. Alright, so now we're going to move on to pH. So on the PowerPoint, we already talked about that, so we do all that stuff. So again, if you didn't get the information, I went too quick, you can read this PowerPoint here. Alright, now pH is the same concept. If you look here, you have one best pH. If you get too acidic or too basic, it slows down. So this is where you have to remember the pH scale too. Alright, so we're going to go here. So all enzymes, so it's basically going to be the same thing as the top. Work at 1 pH, best at 1 pH, and this is called the optimum pH. Alright, so if we did our graph down here, we'll do 6. Alright, our blood is mainly a pH of 6. So what we're going to do is say, okay, optimum, that means it works the best up here. And then if we get too acidic, remember this is the more acidic spot over here. Anything lower than 7 is acidic. Or if we get even close to neutral or too basic, it will slow down. Remember, basic is above 7. Alright, so like if you did 7, 8, 5, 4, it will slow down and then eventually not work. So it works same as the temperature stuff. Alright, so what is the application of this stuff? So we talked about temperature with fever and stuff like that. Well, this is the same reason. We actually have systems that talk about keeping our system. So we actually have enzymes that work best in our stomach, which is pH of 2. But if we take those enzymes and put them in our blood, they won't work. So each enzyme works best at the pH for the environment it is in. Alright, so another thing that you can add to your notes here at the bottom, another thing is that we put food in vinegar, like pickles, and pickles like last forever in the jar. Alright, so food and vinegar, and this will slow down the enzymes because vinegar is very acidic. Alright, so that's another option thing there for a application for why this matters. Alright, so now we just have one more thing to talk about, and this one's a little bit different. And that's substrate concentration. So let's just go back to our PowerPoint here quickly and see. So here, this is what I'm talking about with the environment. Pepsin is in our stomach, so it works at a pH of 2, whereas trypsin is in our intestines, and our intestines are not as acidic. It doesn't have all that stomach acid, so they are at a more basic pH that they work better. Alright, now substrates concentration. So as we add more and more sugar there, our enzymes will start going faster because there's more sugar to bind with and break apart. However, just like you can only run so fast. You can get a little bit faster, but you can only get so fast. Humans can only go so fast, and even you specifically can probably only go so fast, just by the way you're built. That's the same with enzymes. Enzymes can only go so fast. So what you're going to see is enzymes will speed as we add more substrate, add more sugar to the mix. It will lead to faster reactions because the enzymes speed up reactions and there's more substrate to bind with until the enzyme cannot go any faster. Alright, so this is going to be a slightly different graph here. So your graph is going to look like this. So if we say, we'll just make it really simple, 1, 2, 3, 4, 5, and so on and so forth. So our enzymes, we're getting more and more substrate, going super fast, but then all of a sudden they can only bind with so much, so then they stay the same. They don't slow down, but they stay the same. They can't go any faster. So that's the fastest they're going to work. Just like your car. You can speed up, accelerate, but then eventually your car will just bottom out and it can only go so fast. Alright, and now, last thing here. Alright, so now we can show both of these things on the same graph. Alright, so this graph shows that enzyme rate will speed up after, will stay constant, just like we showed before, after the enzyme concentration gets so fast. Constant, I forgot the S. Wow, I spelled that totally wrong. And the higher the line, the closer the enzyme is to the optimum pH or temperature. So let me explain what that means down here as we do our graph. And I'm going to have to do this quick because I'm almost out of time. Alright, so if we have 3 or 4 lines, so this is just like our substrate concentration. Our enzyme speeds up until we have so much substrate that it starts leveling off, and these should all level off, not go back down. That's just my fault. Alright, so if this one, it can only go so fast, this one can go a little bit faster than this one, and then it starts to level off, and this one can go really fast. So that means this one had to be, if we're saying pH, this would be the optimum pH up here, whereas these would be lower. So if this was the optimum pH at 6, then this might be a pH of 8, because it's away from 6, so even though we increased it, it got slower. And then this might be a pH of 2. It's really far away from 6. All right, really slowed it down. All right, so that is the key thing.